Good morning students, welcome to our online video class of chemistry. In this section we will discuss about non-stoichiometric defect and electrical properties of solids. In previous section we had discussed about stoichiometric defect. What is stoichiometric defect? It is the point defect and which do not disturb the composition of the particles. In this section, we will discuss about non-stoichiometric defect. Non-stoichiometric compounds are those compounds in which the ratio of number of positive and negative ions does not correspond exactly to ideal whole number ratio indicated by their chemical formula. Two types of non-stoichiometric defect. First one is metal excess defect. Another one is metal deficiency defect. Metal excess defect. As the name suggests, the metal ions or positive ions are in excess. The defect arises in two ways: by anion vacancies and by cation vacancies. Next, we are going to discuss about metal excess defect due to anionic vacancies. Alkyl halides like NaCl and KCl shows this type of defects. In this case, one or more anions are missing from the lattice. In order to maintain electrical neutrality, the position is occupied by electrons. Here the electrons are actually trapped at this position. An example for metal excess defect due to anionic vacancy is when sodium crystal is heated in an atmosphere of sodium vapors, sodium ions get deposited on the surface of the crystal. The chloride ions from the crystal lattice leaves their site and diffuse into surface. Here they tend to combine with the sodium atom, which in turn get ionized to form Na plus sodium ions, and the electrons that are released are trapped by anionic vacancies. In this way, crystal maintains its neutrality. When sodium chloride is heated in an atmosphere of sodium vapor, some more sodium atom deposited on the surface of the crystal. The chloride ions from bulk then diffuses to the surface and combined with the sodium atom, which become ionized by loose electrons. These electrons diffuse back to the crystal and occupy vacant site created by the chloride ions. The ion site occupied by electron in this way are called F-center. What is F-center? To maintain electrical neutrality, an unpaired electron is occupied on the anionic site, that is F-center. Here the F stands for Farben-Center, which is a German word for color center. This is responsible for the color of the compound. As a result of this, they impart yellow color to the crystal of NaCl. The color results by the excitation of these electrons when they absorb energy from the visible light falling on the crystal. In the same way, vapors of lithium will impart pink color to it, lithium chloride, while those of potassium will make violet in color. Potassium chloride makes violet color, that is lilac. The defect is similar to Schottky defect and is found to be present in those crystals which suffer from Schottky defect. Next is metal excess defect by the presence of extra cation. Positively charged ion is called cations. The metal excess defect also occurs when extra positive ions occupies on the interstitial position. In order to maintain electrical neutrality, an equivalent number of electrons occupies on another interstitial site. This is the metal excess defect by the presence of extra cation. This defect is also found in crystals, which would be expected to form Frenkel defect. For example, when zinc oxide is heated, which is in white color at room temperature, it loses oxygen reversibly and turns yellow in color. This is the equation. When zinc oxide is heated, it reversibly loses oxygen and turns to yellow color. The excess zinc ion formed get trapped in the interstitial positions, and equivalent number of electrons are also accommodated in the neighborhood interstitial position to maintain electrical neutrality. The yellow color of zinc oxide on heating is due to these trapped electrons in the interstitial site. Other examples of compounds showing this defect are cadmium oxide, chromium oxide, etc. Metal deficiency defect. This type of defect occurs in compounds containing transition metal atoms, which can exhibit variable valency. This defect arises in two ways: by cation vacancies and by presence of extra interstitial anions. First is metal deficiency defect by cation vacancies. In this case, cation is missing from the lattice and the positive ion is balanced by the presence of extra charge on adjacent or neighboring atom. The defect is commonly shown by transition metal with variable oxidation state. Common examples of compounds having this defect are ferrous oxide, ferrous sulfide, nickel oxide, etc. Metal deficiency defect by extra anion occupying interstitial sites. In the case, the extra anions may be occupying interstitial positions. The extra negative charge is balanced by extra charges on the adjacent metal ions. Such type of defect is not common because the negative ion usually very large and they cannot easily fit into the interstitial site. We discussed about defects. Defects are mainly classified as point defect and line defect. In this chapter, you have to study only about point defect and its classifications. Next, we are going to discuss about electrical properties of solids. Solids can be classified into three categories based on their electrical conductivity. Solids exhibit electrical conductivities that extend from 27 orders of magnitude, ranging from 10 raised to minus 20 to 10 raised to 7 ohm inverse meter inverse. Conductors. Solids with conductivities ranging between 10 raised to 4 to 10 raised to 7 ohm inverse meter inverse are conductors. And metals are the good conductors of electricity because it have conductivities in the order 10 raised to 7 ohm inverse meter inverse. For example, iron, copper, aluminium, all these are examples of conductors. Insulators are the solids with a very low conductivities and its conductivity range is between 10 raised to minus 20 to 10 raised to minus 10 ohm inverse meter inverse. Examples are wood, plastic, cloth, glass. All these are examples for insulators. Next is semiconductors. Solid with conductivities in the intermediate range between 10 raised to minus 6 to 10 raised to 4 ohm inverse meter inverse. Conductivity lies between those of metallic conductor and insulators are called semiconductors. Electrical conductivity in semiconductors are due to the presence of holes or electrons or both in their crystals. The conductivity of semiconductors increases with increasing temperature, while that of metal decreases with the increasing temperature. Examples: gallium, germanium, silicon. We discuss about electrical properties of solids. How solids are classified on the basis of their electrical conductivity? It is classified as conductors, insulators and semiconductors. Conductors are the materials that allows electric current to pass through it. The conductivity of good conductor is of the order of 10 raised to 7 ohm inverse centimeter inverse. And the insulators are the materials that does not allow electric current to pass through it. The solids whose the conductivity lies between conductors and insulators are called semiconductors.